Hi folks, we're going to take a look at page 303, number 15. So they give us this table of values that give us monthly temperatures for Hamilton. All right, they want a scatter plot, and then they want us to use the graph and the table to determine a model of the data. And we'll compare afterwards. I'll show it on Desmos and see how good our model is. All right, just to change things up a bit, I've been doing a lot of these by converting them into days of the year instead of months. So let's do this one in terms of months. And one thing I notice here is I've got the lowest value is negative 4.8 that repeats itself both in January and February. And then my highest value is 21.9 in July. Okay, so I guess if I want to keep things kind of nice and neat, assuming that the period here is 12 months, that this repeats itself every year, I guess it would make sense to take month 1 to be our minimum and month 7 to be our maximum. All right. There might be an argument, though, to say that, well, here we have negative 4.8 both in January and February. And we know that sinusoidal functions sort of have a symmetry to them, that maybe the minimum would occur kind of somewhere in between these two. All right, so let's first talk about what month 1 means. If we're calling this number of months, well, you have to think that January 1st would be 0. So month 1 would be the end of January if we're going to do this in terms of months. So it would be, January 31st, and then 2 would represent the end of February, and so on and so forth. So when we're determining our phase shift, there's an argument to be made that we could shift it by 1 month, or maybe shifted by a month and a half if we want to assume that the minimum occurs in between these two values. Okay, so I'll just do the rest of the problem, and then afterwards we'll test that out on Desmos to see if one is better than the other. Sorry about that. All right, so let's start by taking our max and our min. So our max here is, I'm going to make my life simple, especially since the max and the min, I think I'm just going to take it as 22. Sorry, I was looking at the min, but hit the max. We'll just take it as 22 to make things a little simpler. And our min here, I'll take that to be negative 5. All right. So we've got our max and min allow us to find our A value and our C value. So our A value is going to be 22 minus negative 5 over 2. So that's 27 over 2. So that's 13.5. And then the C value is 22 plus negative 5 over 2. So that's 17 over 2 is going to be 8.5. Then our period, we're going to assume here is 12 months. So that means our K value is going to be 2 pi over 12 or pi over 6. All right. And then our phase shift, well, since the minimum is very close to the beginning of the year, our phase shift, if we take an unshifted negative cosine graph, if I want my minimum to occur further into January, it means I'm going to be moving to the right. Okay, so my phase shift, and this is where I'll keep it open-ended. I'll say, 1 or 1.5 to the right. Okay, and we'll see when we plot it which one seems better. Okay, so now that we have all our information, we can write down our model. Okay, so the model would be y equals, so we said we're going to use a negative cosine graph because the minimum is close to 0. So it's negative 13.5 cosine of our K value is pi over 6. Okay, and here x minus 1 or minus 1.5, we'll see which one seems to work better, and then plus 8.5. Okay, where y is in degrees Celsius temperature and x is month of the year. All right, so this is our model, and let's see how good it is. All right, so let's go to Desmos here. So I've plotted the points. Okay, let's actually shut this here. So I've plotted the points, and you can see it kind of goes down, back up, and then back down again, and presumably starts to repeat itself. So what I've done is I've done the phase shift of 1, and when I plot it, I see that, you know what, it's actually quite a good model. Fairly good. Okay, seems to be maybe a little to the left. Okay, and let's see what happens when we put 1.5. See if that makes a big difference. And we see that, you know what, kind of shifts everything just a little to the right. Maybe this one's even a little closer, but both models are fairly reasonable. One's a little too far to the left, one's maybe a little to the right, with this second one perhaps being a little better. Okay, and you see here the two negative 4.5s that indicate, you know, that symmetry that these trigonometric functions have. All right, so if we go back to our work here to recap. So when you're working with table of values, you have to keep in mind that what you're looking for is something that's reasonable. So someone else might have made some different decisions, probably would have gotten a graph and a model that would have been, again, fairly reasonable with the information. But again, what you want to look for is minimum, maximum. When it's a yearly thing like this, you're probably just going to assume that the period is a full year. In this case here, 12 months. And then from there, determine all your basic characteristics. As long as you get something that's reasonable, you're doing good. Okay, that's it for this one.